Hello, today we're going to review trigonometric ratios and how to find sides using SOH-CAH-TOA. So when we talk about trig ratios, what that means is that we're going to be comparing two sides of a right triangle using the acronym SOH-CAH-TOA can help us remember which sides to use. Now, to review a little bit, there's other ways to find missing sides of a right triangle. You're probably already familiar with the Pythagorean theorem, and what that means is that if you have two sides, you can find the third side by using the formula a squared plus b squared equals c squared. Okay, so as long as you know two out of the three pieces that are part of the formula, you can find the third. Same thing with trig ratios, but this time you don't need two sides. All you need is one side and then an angle that's not the 90-degree angle. So if you have an angle that's not the 90-degree angle, so like in this case 38, and another side, you can find the other sides as well. Okay, so the trig ratios, as I was saying, is SOH-CAH-TOA is the acronym that we're going to use. The sine is the opposite over the hypotenuse. So when we label a triangle, we can label the opposite and the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So let's practice figuring out how to label the triangle. So we're going to label the opposite side, the hypotenuse, and the adjacent of angle A, and we're going to do that in different colors. So for the first example, here's angle A. The opposite side, that's the one I like to start with. The opposite side is always opposite of the angle. So here's angle A, we're going to go to the opposite side. That's the one that's furthest away. So that's always going to be the opposite. It doesn't matter where the angle is. Like if the angle is over here, then the opposite is furthest away in the other direction. If angle A is over here, the opposite is furthest away. Okay? The other one that's kind of easy to find is the hypotenuse. Remember, the hypotenuse is the longest side, no matter where it is. So here's the hypotenuse, the longest side. Here's the hypotenuse, the longest side. Here's the hypotenuse, the longest side. It's always across from the 90-degree angle. And then the adjacent is the other side that's missing, right? It's the angle that's next to. So the word adjacent means next to. It's next to the angle, but it's not the hypotenuse because the hypotenuse is the longest side. The adjacent is the other one that's next to it. The adjacent is next to the angle and it's not the hypotenuse. The adjacent is next to the angle and it's not the hypotenuse. You could also think about it as the adjacent is in between the angle that you're looking at and the 90-degree angle. Okay, so now we're going to calculate some ratios. And in this example, we have a triangle. It's a 3, 4, 5 triangle. So we have all the sides, so we can actually calculate each ratio. So remember, sine, the acronym is SOH-CAH-TOA. Remember, sine is opposite over hypotenuse. SOH. Sine is opposite over hypotenuse. So the sine is the opposite over the hypotenuse. And in this example, the opposite side, I didn't label it here, but the opposite side of angle A, you have to look at the correct angle, okay? We're not looking at angle B or C. We're looking at angle A right now because this is sine of A. So from A, the opposite side is 4, and the hypotenuse is 5. The hypotenuse is the longest side. So if it's 4 over 5, that is our answer. It's also equal to 0.8, but you can leave it as a fraction. Cosine. Cosine is the adjacent over hypotenuse, looking at our SOH-CAH-TOA. So CAH-TOA, C-A-H, adjacent over hypotenuse, okay? Cosine is adjacent over hypotenuse. Adjacent in this problem, okay, let's look at it. It's angle A. Adjacent is next to it, but it's not the hypotenuse. So that's 3. The hypotenuse is 5. So 3 over 5. Tangent is opposite over adjacent. So from angle A, the opposite is 4 and the adjacent is 3. 4 over 3. We can do the same process, but now we're going to look at angle B. So it kind of changes, okay? The hypotenuse is still going to be the hypotenuse, but the opposite and the adjacent are going to flip. So sine of B is opposite over hypotenuse. So from B, the opposite is 3, that's the furthest away, and the hypotenuse is 5. So 3 over 5. Cosine is going to be the adjacent over the hypotenuse. So adjacent to angle B is 4, the hypotenuse is 5. So we're going to have 4 over 5. And then finally, the tangent is the opposite over the adjacent. So the tangent of angle A is opposite is 4, adjacent is 3. So that's actually a mistake right here. It should be 4 over 3. Let me fix that. Yeah, because opposite of angle B is 3, adjacent is 4. So it should be 4 over 3. All right. So let's go on to example 3. Use the calculator in degree mode to find, and we're going to find the sine of 28 degrees. So you can use any calculator. You can use a phone. You can use a the internet, anything that you need. So I'm going to use the iPhone calculator, and in the iPhone calculator, you're going to type in sine of 28. So what you want to do is you want to turn it sideways, and then you're going to type in the number first, the degrees, 28, and then the sine. The sine is located right here at the bottom left. You can see it. There it is. The sine is at the bottom left. So you click sine, and it's going to calculate the sine. All that does is that it calculates the fraction. Like, remember this fraction right here that we got? This would have been 0.8. Well, guess what? If the angle was 28 degrees, that ratio would be 4.469. Okay? Do the same thing with cosine of 57. So again, you start with 57, and then you press cosine. Cosine is next to the sine. You get 0.544. Let me make sure I type that right. Yeah, that's incorrect. It should be 0.544. And then the tangent of 63, let me make sure that's correct. It's 1.963. So why did I get it wrong? I'm pretty sure that it's probably because I had it in radian mode. Let me just double check that. Yeah. So you want to make sure that you are in degree mode. Okay, what do I mean degree mode? Degree mode means that let me show you on the phone. Right now, my calculator is in radian mode because it says RAD, rad for radian at the top left. You can change that by pressing the degree button down here, and it goes away. And that's the same case in any other calculator that you use. Make sure you are in degree mode. All right. So the last example, example 4, find the missing side. So how do you find a missing side? So let's look at the problem. They give you angle A, which is 34, and they give you one side, which is the hypotenuse is 5. So that is enough information to find the other sides because you have one angle and one side, and the angle is not the 90-degree angle. So let's say that you wanted to find angle A, so side A. Side A is the opposite of 34. Okay, I labeled opposite, hypotenuse, and adjacent. Opposite, so you want to find the opposite and you know the hypotenuse. So you always want to have something that you know and something that you're looking for. So if you're looking for the opposite and you have the hypotenuse, you're going to look for the trig ratio that has the opposite and the hypotenuse because you're looking for the opposite and you know the hypotenuse and the angle. So we're going to set it up because I know the angle is 34, so the sine of 34 is the opposite over the hypotenuse. The opposite is A and the hypotenuse is 5. Okay, the sine of an angle equals the opposite over the hypotenuse. The angle is 34, the opposite is A, the hypotenuse is 5. So we label that. Now, after you have this set up, you can put a 1 underneath the sine of 34 and solve for A by cross multiplying. It's also called the butterfly method because when you circle it like that, it kind of looks like a butterfly. So when you do, I like to do the letter first. A times 1 is A, and you can set that equal to, you can do sine of 34 times 5 or 5 times the sine of 34. I like to put the coefficient in front because otherwise it looks like it's sine of 345. I don't like that. So let's do 5 times the sine of 34, and you can do that in your calculator as well. You can do sine of 34 and then times 5, and you get 2.796. Okay. And then to find the other side, B is the adjacent and you know the hypotenuse. So if you want to find the adjacent and you know the hypotenuse, you can use cosine because cosine is adjacent over hypotenuse. All right. So to do that, you do cosine of 34 is adjacent B over hypotenuse 5. B over 5. You do the cross method again or the butterfly method. B times 1 is B. 5 times cosine 34, do that on the calculator, you get 4.145. And then the other example, so you have you have a triangle again, and this time they give you another angle, angle B, 43 degrees, and you want to find X and Y. So from 43 degrees, remember the opposite of 43 degrees is down here. You go all the way across. So opposite, adjacent, and hypotenuse. Let's find the hypotenuse first. That's X. So you want to find the hypotenuse, and we know the adjacent. So the trig ratio that relates the adjacent and the hypotenuse is cosine, remember? Cosine is the adjacent and the hypotenuse. So we're going to use cosine of 43 degrees equals the adjacent 4 over the hypotenuse x. And we're going to do cross multiply again. But this time we get, I like to start with a letter. So x times the cosine of 43, that is actually x cosine of 43 equals 1 times 4 is 4. From here, what you want to do is get x by itself by dividing both sides by the cosine of 43. Because when you do that, the cosine of 43 on the left side cancels out, and you're left with x equals 4 divided by the cosine of 43. If you do that on the calculator, you get 5.469.